Morning friends, this is Jigar Ratnottar from Atmiya Institute of Technology and Science from Rajkot. Today we are going to start the topic three-phase circuit, that is also known as the polyphase circuit. The contents of today's topics are the advantages of three-phase over the single-phase circuit, the overview about the polyphase circuit, the generation of three-phase voltage, types of connection in three-phase circuit, the control rectifier, one of the application of three-phase circuit, the relation between the line current and the phase current, or the difference parameter used in a three-phase circuit, and the last one is the problem solving. So let's start with the advantages of three-phase over the single phase. There are lots of advantages of three-phase circuits over the single phase, like a small size. Now if you are talking about the same voltage, the rating of the same voltage of the three phase and the single phase, then definitely the size matter. So the size of three-phase circuit is smaller than the single phase, which is one of the best advantage of three-phase circuit. Then the low cost. About the copper wire used in a generation and the transmission of three-phase circuit and a single-phase circuit. So regarding to copper wire used in the three-phase and single-phase, we can say that the cost of the three-phase circuit is lower than the single-phase circuit. Then the better power factor. But obvious, the three-phase circuit has the better power factor than the single-phase circuit, again with the same voltage and the current ratings. The steady output. The three-phase circuit produces the much better output than the single-phase circuit, which is steady output. And the three-phase circuit, again one of the advantage of the three-phase circuit is it has the flexible output. Flexible, it means you can convert the single phase voltage over the from the three phase voltage, but you can't convert the three phase voltage from the single phase voltage. So this is the flexible output which gives the three phase circuit or the polyphase circuits. Now some of the overview or the ideas about the polyphase, which is the three phase circuits. It's a common method of AC alternating current which is used for the power generation, transmission and the distribution. It is one of the type of polyphase system and is the most common method which is used by the electrical grids worldwide to transfer the power. In the polyphase circuit, we know that there are 3-phase, 6-phase, 12-phase, but after the end of the session I am just playing the video which gives you the idea why we can use the 3-phase circuit or not the 6-phase or 12 phases. It is also used to power the large motor and other heavy loads, to operate the large power motors or the heavy loads. A three-phase system is usually more economical than the equivalent single-phase circuit, which is one of the advantage of three-phase circuit, which we already talked about it. See, here is one of the example of the three-phase circuit. The three-phase system was independently invented by the Galileo, Ferraris, Mikhail and Nikola Tesla in the 1880s. In the year of 1880s, there is a one figure which shows you the three-phase circuit. There are generally the 4 wires. The first 3 are the phases like A, B, C. You can also say that the R phase, Y phase and B phase, and one of the wire is a neutral wire. There is a 4th wire that is denoted by N. Now just talking about the generation of three-phase voltage, how the three-phase voltages are generated or it can be obtained from the circuit. There is a one coil, it has some 2 poles, the north and the south. So the coil has the 2 types of stator winding and the rotor winding. As we all know that the stator is a fixed or the steady winding and the rotor is a movable winding. So whenever the alternating EMF or whenever the supply is given to that motor, then what happens? According to the north and the south pole, the rotor is moving, and whenever it moves it cuts the magnetic field surrounding it. So due to that the some of the voltages are generated. And how the voltages are generated, we see that. See the figure which contains the three phases. The first phase, that is the voltages between A and neutral. Neutral is the common terminal, so A to neutral, B to neutral, and 3 to neutral. That is indicated as a phase 1, phase 2 and phase 3. Here I am going to explain you how the three phase voltage is generated. Suppose that is a input voltage. Now it is always starting with the 0 instant. It completes almost the half cycle, like that is pi by 2, or sorry, it's a pi 180 degree. Again start its negative half cycle, that is 2 pi, and cover start. So like this is called my phase 1. Now what happens? The second phase, that is 120 degree lagging this second phase. So it's starting from here. So it's almost lagging by positive as well as negative half cycle. This is my phase 2 according to that figure. This is 120 degree lagging by the phase 1. And the third one, which is almost again 120 degree lagging with the phase 2, degree lagging with phase 2 and almost 240 degree lagging with respect to phase 1. So this is all about the generation of three phase voltages. See, the three phase generator has the three induction coils placed 120 degree apart on the stator. As we can see that the figure B, which has the three phases, three coils, which is almost 120 degree from each other. There is a figure from the inductor motor which contains that three stator windings. The three coils have an equal number of the turns. The voltage induced across each coil will have the same peak value and the same frequencies. This is again one of the figure of the three phase voltage generation. As we already talked that the coils north and south poles are rotating whenever the supply is given to that, and according to that the phase 1, whenever they are cutting the rotating magnetic field, the voltages are generated. Some of the points which has to be considered whenever we are going to understand the three phase voltage, like the three voltages ER, EY and EB. The E is the voltage for the phase R, Y and B. So the respected voltages are also known as the ER, EY and EB. Three phase winding, that between the R1, R2, Y1, Y2 and B1, B2. ER is the voltages generated like that. Three windings is placed like such that R1, R2. So according to that the voltages are generated, that is ER, that is Y1, Y2. So voltages are generated, that is EY, and again that is B1 and B2. So here the voltages are generated is known as EB. You can see that each and every phase are 120 degree apart from each other. All of the voltages ER, EY and EB has the same magnitude, peak values, all of them having the 120 degree phase difference with each other. Now assume that ER, which has the voltages generated due to the R phase, as a reference vector you have to consider any one of the voltage as a reference voltage, and with respect to that we have to design the 120 and 240 degree with the lagging or the leading phase of Y or B, or if the phase is a Y phase is a reference phase, then R and B you have to consider as a 120 degree or 240 degree lagging or leading. And same is for the happening for the B phase. If the B phase is a reference phase, then R and Y as a 120 or 240 degree lagging or leading phases. So if we are saying that from our figure, if I am saying that the R is our phase 1, then, and if the Y is phase 2, and if the B is phase 3, then definitely the R is a reference phase. So we can see that the Y R is origin with the 0 degree, so Y is a phase 2 which is 120 degree lagging with respect to R. So definitely the EY potential of the Y phase, that is lagging from ER by 120 degree, and the same is happening for the B phase. B phase is 120 degree lagging from which phase, that is Y. But if you have to consider that with respect to R, then it is almost 240 degree lagging with respect to R. So it depends which phase you have to consider as a reference phase. Here we can see that the EY is 120 degree, it will attain the 0 position at the later than ER, that is 120 degree after the ER. Then same way the EB which is lagged by the 240 degree with respect to R, but it can be 180 degree with respect to Y. The mathematical equation of all the three voltages are given by ER equals to EM sin theta, which is origin phase, which is the reference phase. So there is no phase difference between any Y and B phase. But if we are taking the EY potential, that is EM sin, but here it is not only theta but the theta minus 120, that minus 120 indicated that the Y phase is lagging phase with respect to R phase, that is 120 degree lagging. And if you are talking about the EB, that is EB equals to EM sin theta equals to theta minus 240. It indicates that B phase is lagging with the R phase with a 240 degree, or you can say that EB equals to EM sin theta plus 120 degree, that is lead the Y phase with the 120 degree. So you can easily indicate the any R, Y and B phase. If we are again talking about the EY equals to EM sin theta, then it means that the Y is your reference frame phase, then ER may be theta minus 120 or EB may be theta minus 120. See the figure. This is star to star connection, which is one of the connection method of the three phase system, transmitter and the receiver. So here you can see that any one of the two voltages become the positive and the negative. So current can be passing from the positive phases, which the amplitude of which phase is higher than the other two phases, and receive from the other side, receiver side, with the phase which has the low highest the cathode value as a negative potential. Now some of the basic properties of the three phase circuit. Three phase system have either the 3 or the 4 conductor. As we all know that the fourth one is a neutral, and the three windings are three phases are required for the R, Y and B, A, B, C, phase 1, phase 2 or phase 3. There are three phase conductors, that is identifies A, B and C. Again it is not fixed that A, B and C. You can also consider that's a R phase, B phase and Y phase. The three phases are 120 degree out of phase with each other. So almost the total time duration of the current conduction time period, that is 360. So why it is almost 120? See, the current always starting from, suppose here 0 position, it have to complete one cycle, then it is 360. So divided 360 360 with the 3 phase. So the conduction period for each phase, that is 120 degree. So R phase conducts the current for 120, Y phase conduct the current for 120 degree, and B phase again conduct the current for 120 degree. The total is 360 degree. The summation of these 3 voltages are, as we already talked about, that ER equals to EM sin theta, EY equals to EM sin theta minus 120, that is lagging phase, EB equals to EM sin theta plus 120, that is 120 leading with the Y but 240 lagging with the R. So if you are, instead of, you can write EM equals to EM sin theta plus 120, you can also write that EM sin theta minus 240 equals to EB. So now the summation of these 3 voltage, E equals to ER plus EY plus EB, ER equals to EM sin theta, Y EM sin theta minus 120, that substitute the value of ER, EY and EB into equation of E. So ultimately we get that by using the mathematical formula, you can almost you can find that exactly the overall voltage of 3-phase circuit, that is E equals to 0. So from above we can conclude, or we can say that in the 3-phase system, the vector addition of all the 3-phase voltages at any instant is always 0, and that is one of the biggest and the most powerful advantage of the 3-phase circuit. Now the circuit can be divided into 2 types. The first one is the symmetrical circuit. If all the 3 voltages have the same magnitude and the same frequency, and they are displayed by the 120 degree from each other, then this is known as the symmetrical circuit. Symmetrical, it means all the phases have the same magnitude. Again we can say that all the phases have the same magnitude, same frequency, and they are separated with each other 120 degree, as we already talked that or we displayed that the 120 degree R, 120 degree Y and 120 degree B phase. So these are the system of our symmetrical system. The second one is the phase